Welcome to The Explainer. All right, today we're tackling Kubernetes, the absolute powerhouse system that's pretty much the engine for the modern cloud. If you've ever wondered how these massive applications we use every day just stayed online and scale up without a hitch, well, you're in exactly the right place.
Okay, so let's picture this. You're building an app, and you're doing it the smart way. You're using containers, maybe something like Docker. And why not, right? Containers are awesome. They wrap up your code and everything it needs to run into this tidy little package that works the same everywhere, from your laptop to a huge data center. But here's where it gets tricky. What's simple for one or two containers quickly becomes just total chaos when you scale up. I mean, can you imagine trying to manually keep track of, update, and connect hundreds or even thousands of these things? That's what we call container sprawl, and believe me, it is an absolute maintenance nightmare.
And that is precisely the problem that Kubernetes was born to solve. The best way to think about it is like a conductor for a massive orchestra. Every single container is an instrument, and Kubernetes, or K8s for short, is the conductor, making sure every instrument plays its part, perfectly in sync. It brings that sweet, sweet order to all the chaos. So let's get a little more formal. What is it? Kubernetes is an open-source container orchestration system. And the keywords there are orchestration and automating. This isn't just about running containers, it's about managing their whole life. Deployment, scaling, everything automatically. So how does it actually pull this off? Well, it all comes down to this really clever division of labor, a brain and some brawn. So a Kubernetes cluster, the whole setup, is really made of two big parts. You've got the control plane, which is the brain, the central nervous system of the whole operation, and then you've got the worker nodes. These are the muscles, the things that do all the actual heavy lifting. Let's break down what's inside each one. So first, the brain, the control plane. The API server is basically the front door. It's the only way in or out. It's how you talk to the cluster. Then there's the scheduler, which is like a master matchmaker. It looks at the work you need done and finds the perfect worker node to do it. And etcd, that's the cluster's memory. It's a super reliable database that remembers exactly how you want everything to be configured. But the real magic, the heart of it all, is the controller manager. It's like a tireless watchdog. Its whole job is to make sure that the actual state of the cluster matches the desired state you put in etcd. This is key. You don't tell Kubernetes how to do things. You just declare what you want. The controller makes it happen. That is a game changer. And now for the brawn, the worker nodes. This is where your code actually lives and breathes. The most basic building block here is called a pod. A pod is the smallest thing you can deploy, and it's basically just a little bubble that holds one or more of your containers that need to work together. On every single one of these worker nodes, you have a kubelet. That's the local agent that gets its orders from the control plane and makes sure the containers inside the pods are actually running like they should be. And finally, kubeproxy handles all the networking, making sure your pods can talk to each other and the outside world. So you see this powerful separation, right? The control plane does the thinking and makes decisions for the whole cluster. The worker nodes just do the work. The control plane says, this is how the world should look, and the worker nodes get busy making it so. This split is what makes Kubernetes so incredibly resilient. If a worker node just dies, the control plane notices, says, hey, reality doesn't match my plan anymore, and it just schedules that work somewhere else. Simple as that. Okay, but Kubernetes is so much more than just a smart architecture. It's a platform, a foundation for building really sophisticated automated systems. And the way we do that is by using established design patterns. You can think of these as like proven recipes for building great stuff in the cloud. Yeah, these patterns are really just well-known solutions to common problems. They fall into these four main buckets. And the great thing is, you don't have to reinvent the wheel every time you want to add logging or monitoring or whatever. You just pick the right pattern for the job. Let's look at a few cool examples. Let's kick things off with a classic structural pattern called the sidecar. Imagine your main application container needs to send out logs. Well, instead of cramming all that logging code into your app, you just deploy a second, specialized logging container right next to it in the very same pod. This sidecar container does one thing and does it well. It handles the logs. And what's so great about this is you can totally change or update your logging system without ever touching your main application code. It's just brilliant. Next up is a foundational one, the health probe. This is the absolute secret sauce behind Kubernetes' famous self-healing powers. All your app has to do is provide a simple signal, like a tiny web page that basically says, yep, I'm okay. Kubernetes will check that signal constantly. If it doesn't get that okay signal after a couple of tries,
It just assumes the container is broken and poof, restarts it, probably on a totally different machine. No 3 a.m. phone calls, no manual intervention, it just fixes itself. And if you want to see the really powerful stuff, you've got to look at the operator pattern. This is a higher-level pattern where you essentially teach Kubernetes how to manage a really complex application, like a database, all by itself. The operator is a piece of software that has the knowledge of a human expert baked right in. It knows how to do backups, how to handle a failure, how to perform an upgrade, so you end up with a database that literally runs and manages itself on your cluster.
So when you combine this incredibly robust declarative architecture with this whole ecosystem of reusable design patterns, well, it's really no surprise that people call Kubernetes the heart of cloud-native architecture. It's way more than just a container scheduler. It's a true platform for building the next generation of powerful, scalable applications. So, from total container chaos to a beautifully orchestrated, self-healing system, that's the journey Kubernetes takes you on. Thanks for joining us for this explainer. Now that you know the building blocks, the real question is, what are you going to automate next?